Hello, let's talk about graph today. Graph are incredibly important data structure. They are very common in coding interview. Many people are scared on graph during the coding interview, especially the people who are new in data structure. The good news is that graphs are very simple, especially in the coding interview. When you code graph, coding is very simple. Graph pop up in everyday life all the time. Let's define graph. Graph is a collection of nodes that may or may not be connected. In the example in front of me, we have got a bunch of nodes that have integer value 1 through 11, and as you can see between these nodes we have got bunch of arrows. um, like here node 1 2 um, 1 to 2 and 1 to 8. Node 3 has an error. You can see node 3 has an error that's point to node 6, and these errors represent connection between these nodes. And to be honest, that's kind of it, a collection of nodes that may or may not be connected to one another. We actually give a name to the node connection. Every node is a vertex in the graph, okay, and we call the connection there these arrows, we call that edges. So graphs are really made of two special things: vertices and edges. um, there could be directed and undirected, and then connection wise there could be connected graph or disconnected graph. In this example we have directed graph direction, so the arrow indicate the direction, so one node direct to two nodes 2, and nodes 2 direct to 5, 5 direct to 7, 7 direct to node, and then 2 direct to 7. um, if an map is undirected or direction does not matter, then there will not be error, just a single solid line. And cycle is very important concept of a graph. A graph can have cycle. If a graph has a cycle, we call it cyclic graph. If I don't have a cycle, then it's not a cyclic graph. The very simple definition of cycle is any area in the graph if there are 3 or more nodes that kind of go in an infinite loop, then um, you have a cycle in that graph. This example between 2, 5, 7 and 2, okay, we have got a cycle. If you traverse between these 3 nodes 2, 5, 7 and 2, you can keep going in an infinite loop. So we have to order of cycle, okay. As far as the space complexity, the space will be big O of v plus e, where v is the number of vertex or number of nodes plus the number of edge is this error. Okay, and the time complexity um, uh, would be the big O of v plus e, same. Okay, there are two ways to traverse graph. One is DFS and the another one is BFS. Okay, in the next video I will discuss how to traverse graph. That's it for this one. Thank you for watching it. Bye. Graph is tree-like data structure where each node gonna have name and each node going to have children node, which is optional. We're going to traverse by breadth first source. The way it work, we want to traverse the graph level by level, and what I mean by that is we want to start the top level and then we go to second level and third level, so on. So first of all I want to start with A and then go to second level B, C, D, and third level E, F, G, H, and fourth level is I, J, K. Okay, so we are going to use Q to solve this problem. So first of all I start with the root level A. Okay, I put the A in the queue. While the queue is not empty, I'm gonna pop this. Okay, let's walk through again. I start with the root node A. Alright, insert that root into queue. I pop until it's get empty. So pop that A and hold that into current node, current variable. Okay, and then insert that into the final array. Right, and then insert all of the child of the A node into Q. So it goes like, I'll put it here, B, C, and D. So this is one level. So when the level is done, then I'm going to pop the first node right here, because the queue is first in first out. Okay, and then make the B is current, and then insert that B into the final array. Okay, and then check all, if that B have a child node, so insert all the child node into the queue. So child node is E, so E is going after D, and then F is going after E. Okay, and E. Alright, now the C, make the C is current node and put the C into the final array, and then check if the C have any child node. So C does not have any child, so moving forward to D, make the D current node and move that D to final array, and then D have two child node. I'm just gonna make little more space. G and sorry, I duplicate this, G, and then H is going to the Q. Alright, so now when this level is, when this is done, H insert in the queue. Now the first thing going out from the queue is E. E is my current node. E is my current node now, and then put the U into the final array and check if the E have any child. So E does not have any child, then move forward to F. F is current. F is going to the final array, and then insert the child of the F. Child of the F is right. Okay, I'm doing some mistake. I just need to duplicate that one. I J is going here, and then now G is my current node, and then G going here, and then making insert the child of the G, which is the K. K is going here. Right, now you can see the next node will be H, will go here, and then I will go here, and then J is next, and then K is final. So the final answer will be A, B, C, D, E, F, G, H, I, J, K. So this is how the breadth first search work. So we're going to implement in Java language next. Alright, let's implement the logic we just discussed. First of all, we need to create a node class. So I'm going to create a static class node. This class gonna have field string name, right, and then list that is type node. This will be the child node. Child node. Then I need a public constructor. This dot name equal to name. Okay, this should goes inside the class. Okay, so that's my node. So the node have a name, a string, and then the node gonna hold list of children. That's gonna be optional, and that's one of the constructor. All right, and the method I need to implement, that will be I'm gonna do public static. It will return the final array. I'll do list, array list, just for the name, and what the name, you can say breadth first source, the method name. So the method, we are passing here a list and the array list. String array. Okay, so we're passing that, and to return the array. Alright, so remember here we need a queue first. Queue, the type is node. Queue new linked list node, right? So that's the queue, and we're gonna start with the root node, so that will be the queue dot add this. So I start from the first node. I should have queue.add this. Linked list. The method add traverse.node in the type queue. Traverse node is not applicable for the argument traverse. Okay. Yes, so this will work because I'm gonna implement the method inside the node. Okay, so this, and then I'm gonna say while the queue is not empty, current equal queue dot pop. There is not pop, there will be pull.